we're being asked to graph this conic section, and this is one that's known as an ellipse. If you don't know what an ellipse is basically it's like a circle, but it's usually stretched out in one direction or another. In kindergarten, you learn them as ovals. We're going to call them ellipses here. And the way you would know that just by looking at the equation that this is an ellipse is because in some ways it's like a circle. Because we have x squared, we have y squared, and this plus sign here. But because the numbers in front of these things are different numbers, it's going to be stretched out more one way than the other, which is going to give it that oval or elliptical shape. The key to graphing any elliptical curve is to make sure that it's equal to 1. So you want the x squared and the y squared on one side. The plus sign in between tells you it's an ellipse, and then this should equal 1. So of course, if it's not equal to 1, step 1 is to make that the reality. So we'll go ahead and divide everything by whatever that value is so that the equation equals 1. So I get x squared over 16 plus this will reduce to y squared over 4 equals straight up 1. Now, Alice goes on and tells you that on the x-axis you'll make some points at plus or minus whatever you square to get this, and on the y-axis she'll make some points at plus or minus whatever you square to get this. And I want to kind of explain the rationale there. The idea here is we're talking about the intercepts, the x-intercepts and the y-intercepts. Because as you guys know, whatever intercept I'm being asked to find, I make the other variable 0. So for instance, if I were to make y equal to 0, two things would happen. I would know whatever points I found would be on the x-axis because that's where y is 0, and this part of the equation would drop out. So what ends up happening is I end up kind of, if I make y equal to 0 and having this whole thing drop out, I'm kind of thinking about x squared over 16 equals 1. And just by kind of thinking about this, I can see that positive 4 would make this equation true, because 4 squared is 16 divided by 16 equals 1. And negative 4 would also make this thing true. Because if you square negative 4, you get 16 again, divided by 16, which also would equal 1. And so basically we end up with a point at 4, 0 and negative 4, 0. 1, 2, 3, 4. 1, 2, 3, 4. And because it always works out that way, it kind of becomes a quote-unquote shortcut by just saying, like, look, once you have one side equal to 1, look what's underneath the x, and whatever you square to get that, put the plus or minus of that value on the x-axis. Likewise, with the y value, a similar thing happens. So I'll do this in green. If I were to look at the y, if I were to like x equals 0, then all this stuff drops out. And we can see that this equation is true. Y squared over 4 equals 1 is true for y equal to 2 or negative 2. So if the y value is 2, the x value is 0. If the y value is negative 2, the x value is 0. Or the shortcut we kind of talk about is once you have the conic equal to 1, whatever you square to get this number here, that's going to go on the y-axis plus or minus that value. So with these 4 points, we have a general idea of what this ellipse is going to look like, and we do our very best to connect them with a curvy, smooth curve. So that's how you're going to do an ellipse, and then the next example you'll see is a similar looking equation. It's actually going to look a lot more hideous, but we'll do some like shifts and stuff like that to figure out what's going on there. I hope this doesn't seem too crazy, and I'm sure if you're patient with yourself, you'll figure it out. So good luck.